Hello, this is a video that is going over application problems. Before we start with this lesson, I just wanted to kind of remind you about the general guidelines for today since I'm not here. You're supposed to complete your warm-up and check answers. You're now watching this video. Once you're done, the sub is going to hand you a worksheet. You're going to complete that. Then you'll turn your worksheet in and make sure you turn it in the drawer, and then you'll start your homework, which is another worksheet. I changed it from math-based to a worksheet, so you'll just complete that, and then if you have any questions, I left the answer keys with us up. Alrighty, so go ahead and get your notebook out. You want to make sure you copy down everything that I write on the slide and everything that's already on the slide. This lesson is actually something we normally do typically at the end of the unit. So today we're going to do it at the beginning, and I know some of you have done substituting, graphing to solve systems, and others of you have just done graphing. So I'm just going to show you how, for today, temporarily, we're going to be just answering our answers based in Desmos. This lesson should be mostly focused on writing the system. The solving part we're going to use Desmos for, and then later on in the unit when you learn the other method or methods, depending on where you are in the unit thus far, then we'll work them out by hand. But for today's purposes, I wanted the main focus to be on writing the system, that kind of your main goal, not so much the work to actually solve it. Okay, so there's kind of a couple steps. Hopefully while I'm talking you're writing these down, but feel free to pause if needed. The first thing we're going to do is define our two variables. There'll always be two in Algebra 1, so you'll always have to figure those out first. The next part, you're going to write your system, which means we're going to write two equations. Then we'll solve it, and like I said, today we're just going to solve in Desmos. Just to let you know, on your unit test and your unit quiz, you will not be able to use the graphing calculator. So just a kind of exception for today. And the last thing is make sure you answer the correct question. So for the first problem, it says the sum, which we know is plus, of the two numbers is 30, and their difference is 12. Find the two numbers. So the first thing, I don't really like this color. Let's change it. The first thing we're going to do is we are going to define our variables. So our variables are number 1 and number 2. And we're just going to use x and y. So we're going to say let x be equal to the first number, and let y equal the second number. Excuse me. So then when we write our equations, there's two separate ones. We have an equation with their sum, which is right here, and we have an equation with their difference. So you can even title your equations to kind of keep your head in the right place. You could technically solve this problem just by kind of working it out and doing some backwards thinking. But after this year, you'll probably solve it using systems because it's more efficient. Okay, so the sum of your numbers is 6. So that 30. So that means that when I add them together, I get 30. Their difference. So when I subtract them, I get 12. So that's kind of our two systems. Now, you could solve for y here and then graph by hand, but like I said, I'm just going to show you how to solve this in Desmos for today. Let's see, so we're just going to type in both of our equations, x plus y equals 30, and then our second equation, y minus x, or x minus y equals 12. And so what you can do is kind of zoom out, and if you click, you can actually click right on top of the graph. So our two numbers are 21 and 19. And so that's what your answer would be. You could write it as an ordered pair, but honestly with the word problems, we normally don't write answers as ordered pairs. We just write them down. Number 1 is 21, the second number is 19. Okay. So let's see, let's go ahead and try another one. So these are both kind of the same thing. We're looking at translating just math words into equations. So the sum of two numbers is 25. So it looks like one of our equations is going to be the sum. And then one of the numbers is twice, one number is twice the second number plus 7. So that's going to be, we can say maybe twice or some kind of idea that these are two separate equations. So we have the same variables for this one. So I'm just going to do this because I'm feeling, I don't know if it's even worth the time, but it seems like it is. All right, so same kind of thing. Let x equal the first number, y equal the second number. So the sum of the numbers, so if I add them together, I get 25. And then one number, let's just say x, it doesn't actually matter, is twice the second number plus 7. And actually, some of you could use substitution with this, students that are in first and fifth period. But again, for today's purposes, we're just going to set them up, and we are going to just use Desmos to help us solve. So these questions, too, we're still looking for the point of intersection. So let's see, x plus y equals 25. And then the second one, x equals 2y plus 7. And so we can kind of zoom in, and we can click on the point, and it's 19 and 6. Those are your two numbers. Okay, so now this is kind of like the first type of application problem that you can use systems to find the answer. The second one that we tend to see involves amount of money, buying things, and another type of number, a totaling cost. So that's going to be what we're going to get into for the last two examples that we're going to do. Like I said, make sure, I know I'm talking fast, but make sure that you're pausing this if you need to copy down everything. I'm going to flip through your notebook when I get back to make sure that you got all the notes in when I wasn't here. Okay, so the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. 2 boxes of envelopes and 6 boxes of notebook cost $17. Find the cost of each. Okay, so we don't know the cost of the envelopes, and we don't know a box of notebook paper either. So that's where our variables are. So we're going to say, and you know, I'm going to use E and N as the variables, but I'll show you how you can translate those to graph it. Okay, so let's say let E equal the price of the box of envelopes, and then let N equal the price for one box of notebook paper. Okay. So those are kind of your two variables. Now, when you're setting these up in your equation, it's really kind of one sentence goes in one equation. So we're saying that when we take 3 boxes of envelopes, so that would be 3E, plus 4 boxes of notebook paper, so 4N, I get $13.25. Excuse me. And then the second equation would be, I'll just highlight it in this color. All right, 2 boxes of envelopes and 6 boxes of notebook paper cost $17. So that would be 2 boxes of envelopes plus 6 boxes of notebook paper is $17. So those are your two separate equations. This is kind of like scenario 1, and this is kind of like scenario 2. So now when you're graphing these in Desmos, in order to, it's not going to graph the variables E and N, so let's just go ahead and change it to X and Y just for Desmos purposes. So let me make sure I do this right. So for Y equals 13, you just want to be consistent with the same variable. So now I'm saying X is the envelope and Y is the notebook paper. So 2X plus 6Y equals 17. And then when we go to graph it, there we go. So 3X plus 4Y equals 13.25. And remember, our goal is we're trying to figure out the cost of each one of the boxes. Plus 6Y equals 17. Okay, and so you might have to kind of zoom out. And I'm zooming back in. You can, we don't want to zoom in too much. Okay, So what the Desmos is telling me is that x is 115, and the y is 245. So if you look back at your variables, the 125 is the x, which is the e. So this is the price of the envelope box, and this is the price of the notebook paper. So that's how you kind of would set that up, so you can translate it. Okay, let's see. Okay, this is the last question we're going to do in your notebook, and this is a very typical solution to systems word problem. So it says a town recreation department ordered a total of 100 basketballs and bats for a summer camp. The basketballs were $4.50. The bats cost $20. The total purchase was $8.22. How many was ordered? So in this case, you really are talking about two different things. Your variables will just say, let's see, baseballs and bats. I mean, like, I guess we'll just say let x, because, like, why not, right? Let x equal the number of baseballs. And then y equal the number of bats. You know the cost. You don't know how many that they bought. So the first situation is the money equation. So that's our first scenario. We're going to put all the money in the same scenario. So it cost $4.50 for baseball bats, or $4.50 for baseballs, $20 for the bats, and the total purchase was $8.22. So if I translate that, I'm going to take $4.50 or $4.50 times the number of baseballs, so x, plus $20 times the number of bats, which is y, is equal to $822. So just think about that logically. That means, makes sense, right? However many baseballs multiplied by 450, however many bats multiplied by 20. When I add the total cost of everything, it's going to be $822. The second equation is actually right here. We only have one other number, but I know the total number of baseballs, and so that's kind of what we use as the second part, is going to be equal to 100. So that means when I add the number of baseballs with the number of bats, it's going to equal 100. So there's no coefficients on that one. It's just x plus y equals 100. Okay, and then we're going to go ahead and solve it. There we go. And like I said, I know I've said 100 times, but don't think that Desmos is going to be there forever. I'm taking it away. But for today's purposes, I wanted you to mostly focus on making sure you can translate, and the solving part we'll do it later. Okay, $8.22, and then x plus y equals 100. Oops. Okay, so you're going to have to zoom out. There it is. It looks like 76 is your x. Oops, 76, and the y is equal to 24. So what that means is that they bought 76 baseballs and 24 bats. On your classwork and homework for tonight, you may use Desmos when you're solving these to help you get the solutions, but please focus on making sure you can set up the equations correctly. Thank you so much for watching, and have a great day.